Okay. Hey, everybody. This is going to be maybe a bit of a LARP. I don't know. Experiment. Have no idea. But the idea here that Dustin and I came up with is you get 6 minutes on the clock. You explain a complicated topic. We're going to get 3 panelists, yes, and I mean you, from the audience, to be contestants. You're going to try to decipher what the presenter just talked about, and then you'll have a qualified judge and myself ask questions. And there are points, and they are worth some amount of sats that Matt will tell you about later. So, and the first topic we have up here is splicing with Dustin, the person who helped come up with the concept. You wanna come on up? Yeah. Okay, so now here comes the fun part. So, would anyone like to be a contestant? Raise your hand. Okay, well, if we don't get at least 3, it's just first come, first serve. Okay, well, hold on, whoa. We got, okay, put your hand up if you want to be a contestant for splicing. Well, you can be a contestant for more than one thing. Okay, Jesus. All right, relax, everyone. It's consensus. People want to know the topics. Brandon has requested it, and Brandon has requested it. So you've chained attacked me. Okay. Topics are splicing, ZK coins, Stratum V2, and PayJoin. Okay? All right, 4 topics, 1 hour. Let's go. Splicing, put your hands in the air if you want to be a contestant. If there's only 3, then we'll just take 3. I only see 3 hands. Okay, there's 4. Now there's 3. Okay, okay, there's 4. Okay, if you don't know what lightning is, please put your hand down. Everyone put their hand down. Okay, people are now putting their hands up. Guys, come on, this is going to take forever. All right, how about this? You 3 people just come on up. We'll figure it out when you get up here. All right. All right. The faster you move, the quicker we can start. All right. Okay. And Dustin, do you have a hot mic? You want to just take this one? All right.
I was told I'd get to see some of the judging details. Is that still in the cards, Tidwell? Okay, so there's a secret list of questions that I am required to answer, but I can't answer them. Our lovely 3 contestants have to answer them. And the goal is for me to explain splicing enough that they can answer them. And I thought I was going to get to see those questions, and apparently I'm not.
You helped us come up with the questions. And the time starts now.
Oh, God, we're already starting.
Let's go.
So splicing is essentially the way you move funds from on-chain Bitcoin into Lightning. It's the way to do it. There were some old ways to do it before. Notably, if you closed your channel and reopened it, you could do with a similar thing as a splice, but that would take about twice as many bytes and twice the fee. Splicing allows you to essentially move funds from on-chain to Lightning, and in the process, that allows your channel balance to change. So if you have a 1 Bitcoin channel and you splice in an extra Bitcoin, it becomes a 2 Bitcoin channel. Now you can also splice out of a channel. So let's say you have 2 Bitcoin on Lightning, you want to get them on chain, you can use splicing to do that. Those are the main 2 things you can do. And the big important thing here, so it's one of the questions I know that I won't say directly, is that you're going to get a lot of cost savings between, you can close a channel and add funds to it. What you're doing is you're creating 2 transactions. So you're essentially doubling the amount of on-chain footprint by doing that, and splicing keeps it to just 1 transaction. The other thing you can do is you can do splices across channels. So this allows you to take funds from 1 channel and move them to another using an on-chain transaction. See, I feel like I've already covered all the questions. No, I want to make sure I get to any potential questions in there. Okay, so do you guys know what a Lightning channel is? Great, okay, so we got that covered. Splicing, an important thing to know, it's a collaborative thing. I wish I knew what their questions were. It's a collaborative thing among Lightning nodes. So a typical splice would be just you and 1 channel splicing funds into it or out of it. But you could also do it across multiple channels that you have, or even other channels that other people have. So that's an important detail. Remember that one. The protocol works very simply, and there's no pitfalls. Yes, questions. I love this. Great.
Do like a coin join or pay join splice so you have like
Question is, can we do a coin join or a pay join type thing? Oh, you got a microphone.
Yeah, can we do like a coin join splice so like maybe say you have like 4 people collaborate on a splice, so you'd be splicing like 2 channels at once?
Absolutely, and that's a great question. We go from the simple to the complex. The simple is I'm going to splice in funds to my channel. The next complex is I'm going to splice funds into 2 of my channels at the same time, or 3 or 4. The next level is I'm going to splice in, and unrelated, and over there is going to splice in as well. We can merge those together using what's called the interactive TX protocol. So that allows basically these splices to become huge coin joins, as long as they're organized well. Oh, I think I know one of the questions. One of the things, yeah, go for it.
How do we find the partners for that?
That's a great question. And there's a big coordination issue with that. The way splicing is designed today, when you do a splice, you advertise to your channel peer that you're doing it with, that you're doing it, and they get an opportunity to join in. But there does not yet exist a protocol to advertise generally, let anyone come in. But even with that one hop, you're able to get your peer to join in, and then they can allow their peers to join in, and then they can allow their peers to join in, et cetera. But there's this thing I'm working on called Splice Script, which is aiming at making exactly these kinds of situations more possible. They're possible today if you coordinate by hand with your nodes, but the goal of Splice Script is to make it more feasible to coordinate with more people doing more complex stuff. Yes?
Are there implications for changing channel IDs when you do a splice?
Oh, that might be a question. It's a great point. So channel IDs, those aren't going to change, but there's a short channel ID. There's 2 identifiers for a channel. One of them is the short channel ID. It's a shortened version, and includes the block height of the channel in it. So this has to change when you do a splice, because you're moving the splice from one place on the chain to another. And actually, we have a prop here of the first splice ever done. And over on the left, you can see this bottom one of 4200 sats was an existing Lightning channel. And that smaller piece on top was splicing in new funds, resulting in a one big channel over on the side. So this is kind of what a splice looks like on chain, so you get a sense of it. Any more questions? Help me out here.
Where does somebody go to make their first splice?
Costco. For going Oh, this is a great question. So you want to use an implementation that supports Splice, and currently there are 2 that do. It's Core Lightning and Eclair. Those are the 2 that support it today. And then, soon the other ones will one
And
day.
they're interoperable?
Almost. They will be. Yeah, they're almost interoperable as long as you don't gossip. But that's something I'm working on right now with the Eclair guys. This isn't working. We're burning time. Speed chess. Speed question. Go.
Are there new gossip messages, and what needs to happen for this to activate and work?
There used to be a new gossip message, but we got rid of it because we realized on the on-chain footprint, it's clear the splice happened. There probably will be new gossip messages needed when we get to Taproot stuff later on. Speed question, go.
What's the worst thing that can happen to me doing a splice?
You can get pinned. Okay, that's time. Thank you. You got this, guys. You got this.
Okay, so now that you know what splicing is, and you know what splicing stands for, wait, did you cover that one? I'm just kidding. All right.
Am I allowed to respond? Is my mic cut?
Lisa's been paying very close attention here, and I will hand the microphone to her first to ask the first question, to contestant A.
Contestant A.
And you're contestant A far left.
Okay.
Michael, contestant A. What is a requirement to start a splice?
Have the future flag on.
Okay, I think contestant B. What's your answer to this?
You have to. Well, I guess you don't have to have a channel. Then you have to go to Costco. Other requirements.
It's an inside joke.
I'm tapped out.
Okay, contestant C, what's your answer to this question?
I think you need to have core lightning.
Core lightning. Okay, I
Is
do
that
like
what-
that answer. Yes, that is always a correct answer. Okay, I think we're gonna pass it to Tidwell for question 2.
Let's just recap real quick on that question 1. I'm vetoing that as a correct answer.
You'd probably need you need to have a channel. and
I
then
will.
You would need to have core
Wait, hold on.
lightning
We're the
and
judges.
feature
We're the
flag
judges.
on.
We'll tell you what the right answer is.
Oh, okay. Sorry.
Excuse me. Lisa, what was the ideal? What was the ideal answer you're looking for?
You need to have a channel.
Okay, so the ideal answer that she was looking for was you need a channel. All right. My question to you is, what happens to a payment while a splice is in progress? Contestant B, we'll start with you.
I don't think it was covered, so I'm just going to take a stab at it. I'm going to say it just times out.
Let's go with contestant C.
Well, from what I understand, there's kind of 2 parallel channel states, one for the old channel and one for the new channel, and they're both happening at the same time until the splice completes, and then the old channel gets kind of orphaned.
Contestant C, 10 points.
All right.
Oh, we have to go to the next one.
I don't think that was really covered. I actually just went to another presentation that you gave a few years
I didn't
ago.
get to see the questions, but you're right. It was not covered.
Okay, contestant C, we'll start with you on this one. What are the on-chain savings when you splice versus opening and close a channel again?
I mean, I think it was 50%. Are you looking for a percentage or an actual byte unit amount?
How do you quantify the 50%?
Well, because you're skipping a closing before, like, I mean, normally you'd have to, maybe it's only, I mean, you normally close and then reopen, so you're skipping a step.
Yeah, it's one fewer transaction.
Cool. Okay, contestant A, what would you say? What are the on-chain savings?
I mean, they said it pretty good. I guess.
I don't think they answered it right. That's why you're going over.
Okay, well, let's see what I can pull out of thin air. No one's got a whiteboard with the answer. I don't know.
Is it 33%?
I don't have a percentage. I just have a byte number.
Oh, you want a byte number? Was it 160?
Oh, how much you would save? So 7 sats for B byte if the.
Contestant B, do you have an answer?
I don't know anymore. No.
Okay, that's cool. Ideal answer is you save 2 inputs and 2 outputs.
Well, there you go. That was the ideal answer, and there's no debating the legitimacy of that answer. Dustin, because no one answered that question right, minus 10 points. So I think everybody, that was the first round of the rapid fire game show. We have a winner.
Sorry.
Yes. So, oh wait, hold on. We have a final clarification. Hold on.
So I think contestant C wins with 10 points, but I think we should give a second place to contestant B for having one of the best questions during the time. So I don't know, was that like runner up for asking whether the channel ID changes? So Dusty gets 0. Yeah. Okay.
I'm up from -10.
Let's go. Absolute value, tied for first, but not really. Okay.
Okay.
Thank you.
Go to the next one.
If you don't mind, we're gonna rotate panelists. We're gonna see if more people. Thank you for participating in the splicing round. Thank you, Dustin. Round of applause, everybody. So our next one up is going to be ZK Coins.
Here you go.
Yay. I'm judging with Jonas Nick. Obviously, I'm secondly qualified for that. All right, so okay, so if you do not know about ZK Coins and your name is Nadav, come on stage. Okay. We need 2 more people. If you, what's a good clarifying question? If you at least know what ZK stands for, but you don't know anything about ZK coins or maybe rollups to a technical degree, I think you're pretty qualified for this panel. Brandon, because you're an organizer of the conference. I'm nervous because I feel like we need to have it. Okay, Peter, all right, come on up. All right. All right. All right, we have Robin. Robin, I don't think you guys understand how hard this is going to be. Robin, you have 2 people up here that are, you know, they know math and they okay. Anyways, this guy knows math.
Yeah, I know.
This guy knows math, but he doesn't know Bitcoin. This guy knows Bitcoin but doesn't know math. I think. Okay, all right. I'm just trying to give you like understand how you gauge the conversation here. Okay.
And Dom's points do not count for Robin. This is cheating. I object. Just gonna throw that out there.
Wait. Hold on. Do we have a do you understand all this?
I understand all of.
Do you understand this? Do you know what ZK coin is?
I don't know what a ZK coin is. I do know what a ZKP is.
All right. We have at least one person to help. I don't know. All right. All right. 1 ringer and 2 other unringers. Okay.
Mics are next to you. There's a switch on it. It's close to your mouth as possible.
Okay, ZK Coins is a new scalability solution that allows to increase the throughput of the base layer to roughly 100 transactions per second. And additionally, it provides great privacy. So it's a privacy and a scalability protocol. And it doesn't require any soft fork, which makes it quite awesome. And it is a so-called client-side validation protocol, which means that I, as a sender, I send you a coin, and you, as the recipient, you are incentivized to check the validity of that coin. We don't want the global layer to check the validity of the coin because we want to remove the burden of verification from the global layer as much as possible, and we want to reduce the blockchain to its main function, which is essentially just to prevent double spending. But all of the validity rules you can check as a client. I send you the coin and its entire history, so all its ancestor transactions, and then you go through all the history and you check each transaction one by one, and if all these transactions are correct, then you convinced yourself that this is actually a valid coin. And if you want to send the same coin to him, you just take the same transaction history, append your transaction, and convince him that the entire history is correct. The problem is, of course, if you do that, the history keeps growing and growing and growing, and that is not very cool, because if you would have to send him gigabytes of data, that would be, like, it would take very long to transfer it to him, and that's just not very ergonomic. So we are using snarks, which is a great compression technique, to simply compress the entire history into a very succinct proof, such that the data that I sent to you is essentially the same that you sent to him and you sent to him. It's not really growing anymore because we are compressing that history into a very succinct proof. And in that proof, all the validity rules are gonna get checked. And yeah, the blockchain is only used to inscribe very small commitments because you can check all the validity rules, you can check that no money has been created out of thin air and that all the rules have been followed. But the thing that you cannot check on the client side is that I didn't send the same coin to, let's say, him. To prevent that, we need the chain. I have to inscribe a commitment into the chain, committing to, I sent the coin to you and not to him. And everybody can check that globally. So we are using the chain only to retain that global state to prevent double spending. And everything else is checked on the client side. That's why it's a client-side validated protocol. And yeah, this has all kinds of great properties for scaling and also for privacy. These zero-knowledge proofs, they not just compress the history, they also obfuscate the entire history, such that, yeah, you don't know that I actually sent the coin to him and then he sent it to him and then you received it. You just know that this coin was valid. You know you received it from him, but you don't know that he had it before and I had it before. This is the zero-knowledge property of these proofs. And yeah, it's actually a token protocol. but we are not shitcoiners. We don't want any tokens. We want Bitcoin in there. So we need some bridges to bridge Bitcoins into that token protocol such that we have Bitcoin tokens on there. And yeah, one nice bridge that we have is BitVM. That is a trust minimized bridge. I think I don't have to talk too much about it. I think in general you have an idea what a bridge is. It bridges BTC into other protocols, for example, ZK coins. And we just assume for now that we have bridges. I don't want to go too much into detail there. But another cool thing about it is that it's compatible with Lightning. You can use that coin and create a Lightning channel within that coin, and then you can speak to the rest of the Lightning network. So even if you are in the ZK coins protocol, you can pay anyone who is somehow connected to the Lightning network. And a couple cool things about it are like that it doesn't bloat the UTXO set. We completely decouple ZK coins from Bitcoin's UTXO set. We could have billions of ZK coins users and still the Bitcoin UTXO set would not have to grow at all. And also it makes blocks easier to verify. If we compare a Bitcoin block full of ZK coins transactions to like a regular Bitcoin block is much harder to verify even though it has way less transactions. A Bitcoin block that is full of ZK coins transactions can have roughly 100 transactions in there, or like, way more. 100 transactions per second, but like it's roughly 10,000 transactions or something, and a regular Bitcoin block has like, let's say 1,000, 2,000 transactions or something. Yeah.
Is it on? Oh, there we go. So I have sorry, not to interrupt your thought, but you said you can bridge the Lightning channel to the ZK coin protocol?
Yeah. I'm glossing over a couple details here, but yes, sir.
I see. And the bridge basically connects them two together, right?
Oh, no. The bridge is just like to peg in big amounts of Bitcoin. Like let's say somebody pegs in 10 BTC into that protocol and then they distribute it to all kinds of users who then have like maybe $100 balance or something. And then they create just regular Lightning channels within that ZK coin and that connects them to the Lightning network. Of course, somebody needs to bridge Lightning to the mainnet Lightning. There needs to be some kind of other bridges as well, like Lightning bridges essentially.
Okay.
But that is not the bridge that I meant to like give value to these tokens.
Okay.
Okay.
Explain how the commitments look like.
Yeah, the commitments are small signatures. Like it's a signature where I sign that I actually gave the coin to you.
All right, it looks like Brandon was taking notes the whole time. That's good. Good thought.
It's not enough.
So you want
Contestant A.
Me?
Yeah. Robin mentioned 100 transactions per second scaling, or 100 transactions per second. Why?
What do you mean, why?
How does it work?
How is it achieved? It's achieved by compressing. Well, I believe it's achieved by making it simpler to compute, and the way it's done is by only having the client verify it and not the entire network, not everyone on the network. And it also uses a compression algorithm to make the data to make the entire history of the coin more readable.
Robin, put that mic down. You're not allowed to say anything. Just remember that.
That's maybe 50% correct.
Okay, so contestant, we'll go to contestant B then.
Okay, contestant B, do you have an answer?
So what I gathered is the reason you can do 100 transactions a second is because you don't have to validate the transactions on layer 1. Everyone's basically sending each other the proof of the previous transactions along with you're sending it to the next person that you're going to send the money to, right? So if I'm sending Tidwell some Bitcoin on one of these, then I would send him the proof along with a signature so that he can verify that my coin that I'm sending him hasn't been respent. or double spent, I should say. And then the one thing that I'm not sure about is how does this go back onto layer one, right? So we're talking about these proofs getting transferred from wallet to wallet.
No discussion.
Yeah, contestant C, do you have an answer to that?
You don't, like normal Bitcoin transactions, need a full Bitcoin transaction. You just need to inscribe a commitment on chain, and so
That's what I wanted to hear.
All right. Well, contestant C, plus 1 point. .615. Okay. How many points are in a number? Okay. We'll start with contestant B on this one. This one's a doozy. We talked about this a few times, but we haven't said it by name. What is the compression technique for what Robin was talking about in ZK coins?
A zero knowledge proof?
Can you give me the specific name of the compression technique?
No. It's not on my notes.
Contestant.
Did you say it? It's not on my notes.
Robin's not allowed to say anything at the moment, unfortunately. Contestant C, we will skip you and go to contestant A.
Unfortunately, I do not know the exact name of the algorithm. I just know that it is. I just know that it is a special algorithm.
Okay, let's go to contestant C.
I believe it was ZK SNARK, which stands for Zero Knowledge Succinct Non-Interactive Argument of Knowledge.
So
I said ahead of time I know what a ZK proof is.
That is correct, and we'll give you an additional 0.1 points. You're at 1.1 points now. Next
question. So we've heard that the sender sends some ZK snark to the receiver. Contestant A, what does the snark prove to the receiver?
Could you repeat the question again?
What does the ZK snark prove to the receiver?
I think it proves I believe it proves that it shows the history of the coin, and it also shows a commitment to say that the coin has not been double spent.
Correct.
All right. Contestant A, 10 points. We are just at the halfway mark. I would love to get more questions in, but we're still learning the timing here. But a round of applause for the panelists and for Robin. Thank you so much.
Oh yeah, and after that, Jonas is giving a talk about it tomorrow. I think 9:30 or so. 9:45. Go to Jonas' talk. This is awesome. It's a hot topic.
Okay. Yeah, I think if we get good and we streamline this process, we might be able to do 2 rounds of questions. But next topic up, we have Stratum V2. And Average Gary. Okay, perfect. All righty. This is like your favorite stage today, right? Look at that jump. Look at that stratum jump. I don't know.
Can I get notepads for all my panelists? Can I help them take notes?
Okay, if you have heard of Stratum, just the word Stratum, raise your hand. But you do not know about Stratum V2. Polster, it might be the ringer.
Now Polstra doesn't know anything about mining.
We'll take Polstra. We'll take Polstra. I feel good about you. I feel good about this guy.
Yeah, bring a notepad though. This one's gonna be dense.
I feel like you'd be too much of a ringer. Sorry, you're in the mining space. Like, come on. I know you want. Wait, hold on. Not you, but behind you. I know you want to be on the last panel. Did you want to be on this one? Okay. Do you know about Stratum? Do you know what that is? Then you're good. You know what a mining pool is? But do you know anything about it besides the name? Okay, in front, yeah, you then. Okay, wait. Okay, next, you were. Okay, think about who wants to be. No, you can come up. You can come up. I'm sorry. People are distracting me. People are like fidgeting with their hands. I was like, wait. Oh. Okay, we have our 3 contestants here.
All right. All right. All right.
All right. Good luck.
So, I have no idea how long these notes are going to go, but it's going to be information dense. There's a lot of points. All right. Okay, Stratum V1 sucks. You don't need to know anything about Stratum V1. If there's any questions about Stratum V1, I'm going to complain that there's cheating going on, so you just have to know that it sucks. Stratum V2 is split into a number of different roles and a number of different protocols. It's in fact not one protocol, it's 3.5, maybe 2.5, I don't know. You'll figure it out. I hope you're taking notes. So the 3 protocols that matter right now, and there's kind of a 4th, but we couldn't figure out what it meant, is the mining protocol, the job declaration protocol, and the template distribution protocol. All of these protocols are done in binary. The framing is pretty great. I think it's awesome. Great framing. Uses less bandwidth than Stratum V1, which again is garbage. You don't need to know anything about Stratum V1. We just use less bandwidth. The protocols in Stratum V2 are cryptographically authenticated, so that you know who you're talking to. Again, Stratum V1 sucks. Better yet, we split the keys so that you have an offline authentication key, and then you have a sub key that is hot, just like a certificate authority. How the protocols are used depends on the setup. There's a few different roles that make sense that we need to care about. You have your full node, your Bitcoin core. You have your mining devices, your ASIC controllers. You have your proxy, and of course you have the pool. So the mining protocol, this is the main thing. Mining protocol is important. It's how we communicate to the device, right? So it gets the shares from the mining device up to the pool, or up to the proxy, and then from the proxy up to the pool. So it's kind of the protocol that replaces Stratum V1. It's really the thing from the pool down to the mining device, or the pool to the proxy to the mining device. It has 2 modes, so it's really 2 sub-protocols. It has standard channels and extended channels. So standard channels are simple. It's just you're just talking to the party. You're just talking to them. It's chill. They just communicate work. So you send a work to mine on, and it can send back like here's shares. So here's valid solutions to the work. Extended channels are fancy. And it's really like multiplexing channels, right? So we have, if you have like a whole mining farm, you might have a proxy. So like think, just like a Raspberry Pi or whatever, it has a proxy there. And we can have all of these different devices connect to the proxy over these standard channels, so normal mining protocol to all the devices. And then you have one extended channel and one connection from the proxy up to the pool. And so it can like multiplex all of this information. So you can have like, the pool can still see like, okay, there's 100 miners and I can see like how much hash rate they all have, but I only need one connection, and I can like have lower bandwidth because I can just have one connection, and I can just send like work updates, like block updates and whatever over that one connection. Great, okay, so that's the mining protocol. It's great, it works great, we love it. It's the best. Yeah, I'm like most of I'm beating my time on my notes, all right? I have no idea if I'm covering the right questions. But, okay, job declaration, right? Protocol number 2, job declaration. This is the like magic of Stratum V2, right? So it says like the proxy, really you use it from the proxy. So the proxy communicating to the pool. So the proxy is going to declare very forcefully to the pool, hey, here's the block template that I'm gonna mine on. It lets the proxy or the miner pick the transactions they want to work on. Of course, we don't actually just like blindly always send all the transactions to the pool because it's a bunch of bandwidth, and the whole point is to not use a bunch of bandwidth. So we send little short hashes of the transactions. We say like, hey, here's some abbreviated hashes or double hash, I don't remember how it works, of the transactions to the pool, and we say like, hey, here's the transactions. And if the pool doesn't know what those transactions are, it can request them. So it can say like, hey, what transaction is that? I want to see it. And this allows the pools to at least like spot check to verify that the work that miners are doing is valid, if they want to. They don't have to, but they might want to. I don't know. And if the pool can say no, so it can say like, oh, job declaration, I know you're declaring this very insistently, but screw you, I don't like that. And then the job declarator is going to say like, okay, well, I was insistent on it, and it's going to immediately switch to a fallback pool, or it's even going to solo mine. So like, it's like, take it or leave it, here's my work, I'm going to mine on this. If you want to pay me for it, that's great. If you don't, that's all right, I'm going to take my money and go somewhere else. And then the last thing is the template distribution protocol. And this is just like the way that Bitcoin Core gives the miners templates. Just like, hey, here's some transactions. It's a valid block. It talks to the proxy, right? So you have all these nodes in the farm. They talk to the proxy. And then the proxy talks to Bitcoin Core, and Bitcoin Core gives it a block template. And then over this template distribution protocol, and then Bitcoin Core, then the proxy says like, okay, now I'm going to speak to the pool, I'm going to do my job declaration, and then it goes from there. Questions? 3.5. 2.5. 3.5. 3.5. The mining protocol can be standard channel or extended channel, which are really fairly different protocols, but they're still the mining protocol. I don't know. Oh yeah. The question was what was the 2.5 or the 3.5 protocols? Yeah, the mining using standard channels versus mining using extended channels are technically counted as one protocol, but they're fairly different.
And what did you call the middle, the proxy protocol? What's the name of that?
It depends on who it's talking to, right? It speaks different protocols. So the proxy can talk to the pool over a mining protocol and over the job declaration protocol. And it can also talk to like Bitcoin Core over the template distribution, or it can talk to the ASICs on mining.
Wow, that was awesome. I learned so much, and I'm a judge judging on the correctness of these answers. This is amazing. So Matt went up there and talked a lot about Stratum v2. He brought up 4 specific points and categories and protocols of defining Stratum v2. Can you name at least 2 of them, and bonus points if you can name all 4? We'll start with contestant A.
4 features of Stratum v2?
I'm going to call them protocols.
Protocols, okay.
I'm going to call them protocols of Stratum v2.
So we have the job declaration, the template distribution, and the mining protocol.
Okay. I mean, you are correct. That's a good answer. Those 3, though, right? Okay, well, we're going to just give that to you. The one that doesn't really exist anymore is what? Job distribution was potentially the 4th one.
The fact that there's a protocol that doesn't exist anymore does not count.
Whoa, hold on. Mute the mic. All right. Still on the website. If it's on the website, it's still, you need to update your readmes. Okay. You want to ask?
Contestant B. When would a provide missing transactions message be appropriate from a job declaration client?
If the mining template contains hashes of a transaction, and those hashes and the actual transaction is not known, because the initial message only contains the hashes.
That's a different message type, but that is correct as far as the timing goes. It has to do with the hashes of all the transactions.
Okay, we will give partial points to contestant B, and then we will backtrack 30 points for contestant A. So we'll give 3 points to contestant B, 30 to contestant A. Okay.
Contestant C. What are, can you list at least 2 network improvements that are present in Stratum v2?
One is a single connection as a proxy. That kind of one single connection as a proxy for the entire mining devices, so that it's just one connection. Okay, and then the second one is multiplexing the channels.
I would say that's not necessarily network specific. That's more of a logic thing.
Oh, pool can see the miner's hash rate.
No, the pool's always like the polls have to know the miner's hash rate.
All right, let's go contestant A. We'll give you a shot.
So better censorship because miners can choose which transaction to mine. That is kind of like
I'm looking for network improvements, right? Like on the wire network improvements.
on the wire,
right?
not
So
like
the one connection, I'll count that because it's simplified, right? But there are other improvements within the protocol that are network specific.
yes, cryptographic authentication. So you know who you are talking to.
Yeah.
Yes.
Contestant C will give 4 points to, and contestant A will give another 30 points to.
For completeness, the other network improvements, end-to-end encryption, noise, and then you're going to binary from a JSON blob.
Okay, thank you so much. Round of applause for Matt and the panelists. And our last, but not least, our topic is PayJoin. And I know Dan Gould and Jad are coming. All right, hold on. Put your hands high if you want to be on this panel. Okay. I don't even, do we have, okay. Now put your hands down if you know about PayJoin. Okay, if you went to Brandon's talk about PayJoin, put your hands down. Okay, we have one right here. Okay. Do we have anyone else want to venture up and learn about PayJoin live? All right. Do you know about PayJoin? Okay, no. Okay. Okay, well, you come on up then, and the gentleman next to you, you can come up too if you want to. I mean, is it?
Our marketing is too good.
Okay, come up. All right, we have our three panelists. We have our three contestants. All righty, and we start.
PayJoin is the simplest interactive protocol to batch transactions between two people. It scales Bitcoin, saves fees, and preserves privacy all at once. So with relation to batching, in the old times, exchanges make individual transactions with people making withdrawals. We can improve on that by having the exchange combine these withdrawals into one transaction, but that's still only the output side getting put together. PayJoin lets you include input from someone else with the exchange's input when you're making these withdrawals. So you have these batches that include not only multiple withdrawals, but also deposits. I started with the coolest thing first. Maybe it's a little more complex than it needs to be, because in the past, the way this started was as a privacy protocol, where you have a sender and a receiver in a merchant environment where the receiver proposes an endpoint that the sender and the receiver can coordinate at. The sender makes a proposal that's a typical fallback transaction, an original PSBT, that's just the sender paying to the receiver. When the receiver gets that transaction as a PSBT, partially signed Bitcoin transaction, they have the opportunity to augment it and return it to the sender. So sender sends an original transaction to the receiver. The receiver can augment it, meaning they can include an input and increase the output that's paying them by the amount of the input they contribute, sign it, and return it to the sender. If the sender thinks it's okay, they also sign it and have the ability to broadcast it to the network. To prevent the sender from probing all of the inputs in the receiver's wallet, just checking out, oh, what inputs do they have? They'll respond to me. the original PSBT has to be totally signed and valid. So the receiver always has the opportunity to fall back to a naive transaction and broadcast that. The protocol is done over HTTP. So you only need a web connection. And in the version 2, so the version 1 protocol required a synchronous environment where the sender and the receiver are both online and probably have a hot wallet. The version 2 protocol is asynchronous because it introduces a PayJoin directory server that can store these requests and wait for the counterparty to come online. So a sender will post a request to the subdirectory, the receiver will poll GET requests until that request is populated, add their inputs and outputs and return it to the sender, and then the sender's doing the same thing. They're polling this directory for an update when they send. When we introduce this directory, the requests are encrypted and authenticated using hybrid public key encryption. That's based on primitives already in Bitcoin Core, so SecP 256K1, SHA 256, and Cha-Cha Poly 1305. I know you're not going to be asked about this. Don't worry. You better not ask about it because that's specific. And in addition, the V2 protocol requires oblivious HTTP by default to hide the IP metadata from the directory. So the directory is untrusted or trustless. It's blind to the contents. The way the privacy benefits work, because I started with batching with this cut through where your depositor can send to an exchange that pays the person withdrawing in one transaction. That saves in 2 ways: by not creating change for every single receive, by not creating multiple coins in the exchange that the exchange has to pay for, and by sharing the 14-byte overhead that every transaction has. So you multiply that by the number of transactions you would make, and that is your savings. But the privacy comes from the breaking of the common input heuristic, where anyone can assume all the inputs in a transaction come from the same person. And Satoshi even mentioned that in the white paper, but as long as inputs are coming from multiple people, because you're using an interactive coordination mechanism, you break that heuristic. It's just no longer necessarily true. And the PayJoin transactions are covert generally because they may take the same form as transactions where all of the inputs do indeed come from a single person. There are other privacy concerns when you're making PayJoin because there's other heuristics beyond the common input heuristic. So there's a lot of special coin selection you can do, but you guys have 30 seconds to ask me questions before I put the mic down.
What is the key that the sender uses to communicate with the receiver in the coordination?
It's shared out of band in a BIP21, so it's just like in a URI, it's in a QR code. So you put it in the QR code and you scan it, and it's already communicated.
Name the encryption protocols again.
No.
Okay, PayJoin. I hope you're ready. Contestant A, how you feeling?
I'm doing good.
All right. So, first question goes to you. My question is, we talked a lot for some reason about previous PayJoin stuff, so we might as well talk about it and how it's been improved from the olden days of PayJoin to nowadays. Originally, Dan over here talked about it being synchronous, and then he talked about newer methods being async. How do you accomplish this newer async method?
So there is the server itself, the HTTP server, is a blinded server that they're communicating with to drop in the PSBT transaction as a hold, and then the receiver is deciding when or asynchronously at a different time it's picking it up to make its change and then sign it, and then the sender decides whether they're going to commit to that.
I'll give you that. Contestant A, 10 points.
Contestant B.
Hello.
How is the page one directory prevented from knowing who's transacting together in the page one?
I don't know.
C.
The sender and receiver communicate a shared key out of band, and the directory is just being sent partially signed Bitcoin transactions. But I guess it's encrypted using that shared key.
It's half points. Half points.
Okay.
The other,
Dan, you're not part of this anymore. All right. Dan might be objecting, but non-verbally. So Jad over here gave half points to contestant C. So it means contestant A, you get a chance for the other half potentially, if you want to chime in.
Oh yeah, sure. I mean, all these users are using Tor. You know, that helps hide from the server.
close. It's not Tor though. It is OHTTP, which hides the IP addresses. So.
All right, so there's your official answer. Do you want to repeat that answer for everyone, including me?
Yeah, so the encryption part you mentioned hides the actual payload from the directory, but to hide the IP addresses of the sender and the receiver, all requests go through an OHTTP relay, which is kind of like a one-hop Tor. You can think of it like that.
All righty, on to the next question. We'll start with C.
Okay, and the last question is, what is the receiver recourse if the sender goes offline?
They have been sent a signed transaction that they can post on chain.
Hey, contestant C, 10 points. That is correct. I don't think we did a official winner, but I think with the half point and the correct, I think we have a winner here, contestant C. Second place A, and top three, contestant B. Yeah. All right, thank you, Dan. Dan, that was pretty good. Dan, I think Dan did a fairly good job. Okay, Matt, you had a lot of material. That was hard. Yeah. All right, so hey guys, we ran a couple experiments here today. One was the rotating panel idea with Meevil, hosted by Matt. This was this rapid fire idea game show. If you like these experiments, if you have any feedback, if you think we should be doing these next years, maybe expanded or the same, like let me know. TABConf is a test bed for ideas and facilitating discussions. So please, your feedback is crucial to me. That is the end of today. We do have an after party, official after party at the brewery, Rooftop Brewery, that's on the schedule. I do know that Walton and Lisa put on a happy hour if you're trying to crash that last minute and then go. Or you can just hang out here for half an hour and then go to the official after party. And we'll have food, snacks, drinks, and stuff there. Yeah, thank you. I think today's been great. Thanks. Yeah.